Hey, Nick Kennedy here, president and owner with the revolutionary Flex CNC machine tool. Hey, stay with me for a quick second. I'm gonna give you guys a quick tour. Is this something you see in your shop? Looks like a pretty big problem. Look, if you're gonna invest into a CNC machine, don't you care about bed size? What size parts are you gonna run? What size parts do you want to run? Maybe a better question, don't you care about flexibility? Well, come with me, check this out. This is the Flex CNC machine tool. Every machine tool we build, we give customers size and flexibility. This is our standard edition 20-foot long VMC. Don't be limited by a small machine bed. What we're building is the strongest, the longest, and the best priced CNC machine tool in the world. Experience massive action with us, don't settle, size matters. Click below to start making money for your shop. Hey, today we're gonna show you a pretty cool application, 20-foot long piece of tubing, set it up on the CNC, one op. We're gonna go through the top side of the part with the drill in this case, wrap it through and then drill through the bottom. No flipping of the part, just setting up on the machine once, hit and cycle start, super fast. Again, nothing's gonna be faster to process a job like this. You can see how long these things are, how heavy they are, how difficult they are gonna be to set up on any other machine. What we're gonna be running is 1 13/16 drill. About a little over 12 inches long because we have to go through both sides of the tube. Again, so we can do this all in one op. We don't have to flip the part. We don't have to do multiple ops. We're gonna set up on the bed and do it all in one setup. We're gonna hear a little bit of some squawking just because it's such a long drill, but it's the only thing we can use to get it all the way through the part in one setup. So that's it, running the 20-foot long tube, got 9 holes. It takes us about 9 minutes and 25 seconds. So I mean, that's super fast for such a big part, such a big hole, especially to go all the way through. Again, no better machine to run that on other than the Flex CNC, G-Series, big gantry. Give us a call, 800-837-2503, and let us do a time analysis for you and show you how you can save a ton of machine time using the Flex CNC big bed gantry. What we're making are long bed, wide bed, vertical machining centers. The bottom line, they're custom bed machining centers for an affordable price to give shops an option to get into a big machining center to do big parts so they don't have to buy $1 million bridge mill or something that's just completely out of their budget. We're changing CNC machining with our capabilities and design. So if you need it, give us a call. We can build it and make it suit your needs. Hey, Nick Kennedy, Flex CNC. Hey, today we're doing a time analysis for a customer doing some dynamic machining in a block of aluminum. So what we did, we went and reached out to Kennametal to source a really nice end mill so we could really get our machine times down. And to explain this end mill a little bit, this is a 3/4 inch Kennametal Maxi Met. With this guy, we were able to take a 3/4 inch depth of cut, a 225 thou width of cut, and feed it around 90 inches a minute at 4,000 RPM on the Flex CNC. What we're going to show you is how using this tool versus your traditional 3/4 inch end mill, we're able to take our time from 10 minutes and 30 seconds down to 1 minute and 50 seconds. So using the Delta controller on the Flex CNC and high-speed tools, we're able to take a part like this and whittle it down in about 1 minute and 50 seconds. It's an awesome time analysis. The Flex CNC gives us a ton of machine bed to work with, and we'll be able to show you all those details and how setting up parts like this, we can set them up in stations and literally every minute, 50 seconds, make a part like this, nonstop. Using smart programming, great tools. Give us a call, 800-837-2503. Let us do a time analysis for you and show you what we're able to do with that Flex CNC and how we can help you make more money on your next job.
Size matters. Don't run your large parts on a small machine bed. Call 1-800-837-2503 and experience massive action.
What's up, everybody? This is Eddie from Flex CNC, and we are coming at you live from our beautiful facility right here in Wapak, Ohio, via Facebook. We're coming at you via YouTube Live. We're doing everything to make sure we can do this amazing demonstration for you. We have an awesome demo that we're going to be doing today. We're going to be using our Flex CNC. We've got a 2004G series with a high output package there, and we're going to be doing some coping on some structural C-channel on a part that's up to 18 feet long using some special Kyocera tools. So with that, before we get started, I wanted to let everyone know this is a live and interactive stream, so we want to make sure that you engage as much as possible. So we have our chat screen. It should be on this side here. I want to make sure you leave any comments, questions that you may have so we can answer your questions and engage with you, pull those up in real time. So before we get rolling, help me in welcoming one of our special guests from Kyocera, my man, Matt Newman. Matt, how are you doing today, man?
I'm doing good, Eddie. How are you today?
No, it's a fantastic day to do a demo on the Flex CNC using some Kyocera parts, man. So that being said, hey, man, tell us a little bit about yourself and what it is that you do at Kyocera for our fans that are interacting with us on the stream.
I'm a design engineer for our indexable cutting tool division that's here in Wapakoneta. And so we build all of the indexable cutting tools, all the steel products, boring bars, end mills, drills, turning tools, those types of tools.
Well, awesome. Well, definitely appreciate it. Thank you so much for joining us. So we're going to get rolling a little bit in our demo. And before we get started, feel free in that comment section, let us know where you're joining us from right now. We'd love to know who we can connect with around the country and even the world. So I have my handy help here, my handsome man, Aaron here. He's going to tell us a little bit about what we're doing with this specific part. So Aaron, what are we doing, man?
Hey, holler at Fred. He's on the stream.
We got Fred on the stream. Fred, what's going on, you stud?
So we got two Kyocera tools here. The first one that we're going to be running is their hole shot drill. I'm running this guy at 2,700 RPM at 5.4 inches per minute. And then the next tool following up after this tool is I've got a 1-inch indexable mill. And I'm going to be running that guy at 2,250 RPM at 47 inches per minute. And I will let Matt talk about that. So Matt, I know running in steel. I'm going to talk about this drill first. It sounds backwards to run a drill at a high RPM through a steel. Can you kind of tell us why we're able to do that with this particular drill?
With the structural iron and the low carbon steel, you have a very difficult time breaking a chip. Our experience has been with our M1A. Our 1230 brake.
Hey, we're having a little bit of an audio disconnect. So Matt, we want to make sure we hear exactly what you're saying. So do you mind, while we get this tied up, can you repeat that for us, please? It sounded like it was definitely valuable information we want to share with the audience.
Hey, can you hear me?
Yeah, absolutely.
Eddie, can you hear me?
Absolutely, we got you.
Oh, yeah, you got it, Matt. There we go.
There you go. Hit us with it again, Matt, could you please?
All right. We run that higher surface footage and a low feed rate because that is the structural steel being a low carbon. It's very difficult to break the chip. So we have found with our M1A chip break.
Well, good deal. Well, good deal. While we get some things loaded up here, any of you that are working with current structural parts like C-channel I-beams, make sure you leave a comment in the section there. We'd love to hear a little bit more about what it is you're doing and potentially connect further on how we can help you with your specific channel that you have.
Let me go ahead and keep going there.
All right, yeah, I'm going to get it running.
Eddie?
Yes.
Got us?
Mm-hmm.
I'd like to check. All right, I think he was getting some interference, no big deal. Drive on.
Yeah, no worries, no worries. Everything's looking good. You want to kind of keep it running. What's the next step? So what, actually, if you don't mind explaining, what did we just do and then what's next?
Yeah, so we just drilled the 2 holes there with the hole shot drill. Now we're using this to cut essentially the legs on the C channel down at it is a little bit loud. The legs on this particular part is just over 3 inches long. So we do have a little bit. So there's a little bit of chatter on the entry into the material. But as you can tell, this cutter handles it really well as soon as we travel in the extra. It's fully engaged.
No, that's solid. So with this specific tool, Matt, I was curious on your insight. Are there any other solid applications that you would recommend or be able to tell when this specific tool really shines?
W line of cutters, they work really well for general milling. That insert is double-sided. Each insert, so it helps with your expense on inserts, that type of thing. Surface finish, as Aaron is stepping down on that part, because of the way that insert is. An excellent general purpose milling cutter.
Okay. Now, are there any other Kyocera tools that you would like to essentially showcase that would do something similar to this application here?
Yeah, we have our line of high feed cutters, like our MFH. It's available from 3/8. Being the high feed, it's capable of feeding, depending on your material, you can be in a 50, 60 thousandths per tooth. Cutter offer.
Okay. And as we can see here up on the live screen, man, this tool is just putting in work right now, man. Look at this thing just eat through that. I mean, it's doing really well, Matt. What do you think about the way it's working right now and the sounds you're hearing?
Looks good to me.
Right on, right on. Well, as this is working and we're getting letting the mill do its thing, we're going to feature a little bit of what we have with a current C channel that we've used. So whenever we get a second, we'll get that camera, we'll get it turned over here, we'll get a focus to see a little bit about what a finished part's going to look like. So nothing too crazy here, but we're going to be able to check a little bit about how the finished part looks when we're done. But this gives you just a general idea of what we're looking at, starting with this standard C channel. Remind you, this is again a smaller part. We can do parts of, up to 18 feet and larger like we're doing on the machine right now, but this just looks good. We're talking about clean cuts on the drilling, doing a really good job. We're not seeing a ton of markage here. I mean, it looks like a relatively clean cut. And obviously a lot of these applications are going to be high quantity. So being able to bust these out in a timely manner is going to be highly beneficial to anybody who's doing some of these industrial types of copings, or coping, if you will, on the C channel or I-beams. So good example there. Really good example.
Now we are getting some more chatter here now that we're down towards the bottom. And because of the fixturing that we have on here, it's probably not best case scenario. But once you get down towards the bottom of the part, you get like a thinner wall there, so it creates more vibration, and that's a lot of the screeching that you're hearing there. Once it gets into the cut, if you can, Eddie, you can hear the difference. It sounds screechy, and then as soon as it gets into the cut, there it sounds nice and good. Okay. So with having, kind of a small amount of vices just here in-house, holding on to an 18-foot piece is kind of difficult. Oh.
Hey Eddie, some of our other tools that we also have that would be really good in this application would be our chamfer mills. So we offer those in angles from 3 degrees through 75. Great tool for laying chamfers, doing some deburr work on that part when it's done.
Okay. Well, tell us, I'm curious. So obviously you're an experienced guy in these specific realms. Tell us what your favorite tool is to use and why.
I guess since our design special tools, our special tools that we do. So we get into a lot of different things with that. Cutters, that type of thing. So all of our standard products are great, but like I said, 20 some years, that's my thing that I like.
Now I'm curious, so what is one of your largest, most heavy-duty tools that you probably feel is maybe one of your most popular as well?
Probably cutters. You can remove a lot of material with those, in small amounts. The other one would be, probably our full shot line of drills. We actually have up to a 4-inch drill.
I know we've heard, because we're doing a little bit of homework, and we know that the hole shot drill, that's one of your most popular drills. Why is that, man? Tell us a little bit about it.
That phase back design on the front of it. Bigger drill and a smaller machine. As you get to those bigger drills, like the 2.5 inch, so instead of just making the insert bigger and bigger to be able to cover that area, we stack more of the small inserts in there out of the drill body, out of the hole. So it'll leave you with a really nice surface finish. makes it easy to get that chips out of the hole, makes it easy to manage that. So.
Okay. Yeah, we've just heard a lot about this hole shot drill. I'm like, you know what? Let's go to the expert himself and figure out what makes this thing so unique in particular, man. So.
Inserts in there.
All right.
Out of the drill body, out of the hole.
Okay. Well, hey, it looks like we have a question, Matt. Looks like we have a Tyler Albert who. Let's pull that question up here, so we can get this off your way, because I think you might be able to answer this one relatively well. Tyler Albert, my man, thanks for commenting. He says, can this machine bore holes and in the web of the channel? So do you want to tell us a little bit about some of the boring tools that you have on your end over there at Kyocera?
Yeah, we have like the hole shot drill that we showed. So we did actually, we drilled a couple holes in the web of the C channel there. We also offer our Core Master core drills. So if you have an existing hole that you need to enlarge, you can use those. And we offer several different drills depending on the application that you have. We have our line of DRA drills. They start clear down at a 3/8 diameter and go up through 1 inch. And we have drill bodies up to a 12 times depth cut. So those are great for small holes, something really deep. We also have our line of DRZ and our DRV drills around the 5/8 diameter and go up through 2 inch. Those are actually capable of being offset in a lathe, or you need to adjust the size or something. You can actually offset those drills to hold your size better.
Okay. Very nice, very nice. Now, one question I want to ask is, obviously, the hole shot's a very popular drill. So anybody in our comments section, please let us know. Have you used the hole shot drill? Let us know, man, because we know it's obviously a popular piece of tooling. So we appreciate you talking about it a little bit. So, what do we have here? Let's check this bad boy out.
So Matt, I'm having Eddie show off the hole shot drill there. I know we were having some audio issues earlier, but now that everybody can see this drill firsthand, can you kind of explain why there's 2 inserts, what each insert does, and kind of talk about the grade of insert that we used on this material?
Yeah, that's our DR1102. So it's just a little under 1 1/8 inch diameter drill. It's using 2 of the WCMX 050308 inserts. One of those inserts is cutting at the center of the hole, and the other one is actually creating the diameter. And it does have that kind of a phased back design. And that design allows that drill to be stack plate capable. So if you have thin plates and you want to stack up several of those to be able to drill multiple plates at one time, that drill is capable of doing that. So, and like I say, that phase back design also helps with using less horsepower. So as you get into the bigger drills, once you start 2 1/4, 2 1/2 up through our 4-inch drill, you can run those on a smaller machine. You don't need the huge horsepower to be able to use something like that.
Awesome, awesome, man. We got another piece here we want to show?
Yeah, so Matt, again, here's the, we might have touched base on it a little bit earlier. Here's that 1-inch indexable end mill that we were using in the program. Can you go ahead and do the same thing, talk about this one and why it worked with the application that we have?
It's our MEW 1000, and that is a 3-flute milling cutter using the LOMU 100408 ERGM insert, and that is in our PR 1535 Mega Nano Coat grade. Again, that tool, the insert is designed that it can actually be flipped over, so it can be used 4 times. Most milling cutters that are a 90-degree lead like that, you're only going to get 2 indexes out of the insert, but this one you can get 4, so it brings your cost per cut down. And also, due to the helical edge of that insert, when you have to step down the side of a wall, will leave you a very nice surface finish. You're not going to get huge steps out of it. Going to leave it a very nice finish for you.
Okay, well, hey, it looks like we have a question here from Ricky Cruz. Hey, Ricky, thanks, man. We're gonna pull that up one more time so I can read it off. I apologize. What conditions do you have, meaning RPM and feed? It's not like this is a question for Matt. You want to tackle this one, big guy?
Yeah, the whole shot drill that was running at 2,700 RPM, 5.4 inches a minute. That works out to 700 surface feet and 2,000 feet per tooth. And then the milling cutter was running at 2,250 RPM and 47 inches a minute. That works out to 600 surface foot and 7 thousandths per tooth.
Right on, right on. Well, hey, well, Isaac, do we happen to have any other general questions? I want to make sure we can get these things pulled up and get Matt as involved as possible with us having an expert on the line here. Unless we're moving into second operation.
Have we shown the setup? And then he's going to talk about the part.
Okay, okay.
Yeah, let me move the machine bed down here so you guys can see this
Good deal.
full 18-foot part up here. And then
What we'll do, we'll feature, with this being a little bit of a longer part, I mean, it does showcase a little bit of the capabilities. If you want to talk a little bit about the fixturing and why we're using this specifically, go ahead and tear it up, man.
Yeah, sure. So, you know, for this demo, most of the work was down here on this end of the bed. That's why I've got 2 Kurt vices here. I did have to use a double Kurt vise. The single, just standard 6-inch vise was not wide enough to hold onto this part. So I did have to take the center out of the jaws, take the vise jaws off. So like I said earlier, it's not the ideal situation, but it worked out for this. And then I've got a third vise down there on the end to kind of just hold on to the tail end of this guy. I did have to jack it up a little bit with I got some aluminum stock under there. That way when I drilled through the hole, I didn't drill into the vise. But, you know, anybody out here that's doing this kind of work, you know, if you've got work holding suggestions or, you know, kind of explain what you do, why you do it, feel free to, you know, comment, get a hold of us. And then, you know, same thing, having Matt on here, talk about the tooling. One thing I do want to mention, I mean, if you notice, I didn't really talk about the tooling a whole lot. Matt was our Kyocera expert. Any tooling that you've seen here or any tooling that Matt has talked about, you know, feel free to get a hold of us or, you know, get on the Kyocera website. They're the experts. If you're looking for a specific tool or you've got an application in mind, but you just don't know what tool is going to work best for it, we can help you figure out who the sales rep in your area could be. So feel free to get a hold of us and we can shoot you in the right direction.
Yeah, absolutely. And again, if you're joining us on our live stream, make sure to let us know where you're at. We're located in Northwest Ohio, so we love to know who it is we're connecting with on any given time. So with that, the way that it ran, I mean, what's your general feedback? How does this thing look to you, man?
I mean, it looks pretty good for the circumstances. I mean, like I mentioned, the legs on the channel itself are kind of tall. So sticking that tool out, that's why we heard a lot of the chatter. That tool is sticking out about 3 1/4 inches long. So anytime that you lose your rigidity, that's where the chatter comes in, the noise, the extra noise that you were hearing. But overall, I mean, the tools ran great. I was happy with them. And Matt, I appreciate you kind of hooking us up and getting a good demo for us.
Yeah, and then the last question I had, so obviously we have a lot of fixturing here. So Aaron, why is it that we use the machinist vise as opposed to one of our pneumatic vices that we can typically use?
So the pneumatic vices here are really good for any kind of down pressure. All of your drilling applications, tapping applications, that's what these pneumatic vices are really good for. Anytime you've got milling applications where you have a lot of side pressure with your milling, that's where the machinist vise, you know, it's really rigid, it holds the part nice and sturdy. So that's kind of the reason behind the Kurt vices there.
Right on. No, I appreciate that. And then just as a quick reminder, we are going to be giving away some Kyocera swag. We have some hats here as well as some coffee mugs. So make sure to leave your email in the comment section. If you're joining us in Facebook, message us directly. We want to make sure we can enter you in the drawing to win some awesome Kyocera swag. So with that, Aaron, are we doing any other operations today or anything else that we need to cover?
I don't think so. Matt, if you got anything that you want to add?
Yeah, maybe any questions that we may have for Matt in the chat section?
Comment separately. He wanted a little more detail about the feeds and speeds. Hey, let's talk about.
Okay. Well, no worries. what we're going to do, just quick while we have everybody here, we're going to really kind of phase up. We are doing a lot of different live streams. So one exciting one that we are really excited to do is we're going to be doing flow drilling here. So we're going to be using this bad boy here right on the CNC. I'm going to grab a beautiful part that we have to give you a general example of what it is we're looking. And while I'm doing that, Isaac, could you cue up that MPT video? We'll get that going here in a second. But one moment. And this is just a little sneak preview of the beauty we're going to be rocking out here in the near future. Just look at a general part we've done before, done a couple of test runs. Just real beautiful here, real beautiful.
I'm going to go ahead and comment on this. So what the whole size that you're seeing here is for a 1/2-13 tap. Here is the flow drill that we will be using. It's 2 5/8. So you see the massive difference here. We're going to be dealing with a lot bigger material. We're really excited to get on this video here in the near future.
Oh, it's going to be gangster. Absolutely, absolutely. So we appreciate everybody. Before we send you off, we're going to be doing another demo. We're going to be doing MPT testing MPT tapping, if you will, with our good friends over at OSG. We're going to have their VP of Sales, Danny Nichols, joining us. But hey, Isaac, can you pull up that B-roll? Be nice to our, our West Coast folks. So with that, unless we have any other B-roll or general questions, is there anything else we need to answer while we have Matt on the line? Right on. Well, hey, Matt, if you're still there, we want to appreciate you so much. Thank you. Is there any other sending off words that you need? And just to let people know how they can get a hold of you or learn more about Kyocera products?
No, like I say, they can check out our website, Kyocera Precision Tools, and everything's on there, contact info also. So.
Well, awesome. Well, we thank you for being amazing neighbors since you're literally, a couple buildings down from us. So it's always good to have you in-house. But unless there's anything, we want to thank you all so much for joining us. Please remember, subscribe, you turn on those notifications so we can keep in the loop and give us what my daughters would say is a huge thumbs up. So thank you all so much, and join us next week for our MPT tapping demo with Danny Nichols, VP of Sales at OSG. Stay awesome, stay flexing, and we will see you next time.